Today's Toolbox Tech Talk is a deep dive into EJOS, Arvio Australia's amazing monitoring control system for inverters, smart energy appliances, and much more. We're going to spend quite a bit of time listening to Paul demonstrate EJOS. So sit back and enjoy the ride. G'day, I'm Glenn Morris from the Small Energy Lab, and today I've got my friend Paul Wilson here from Arvio Australia. Paul and I have known each other for, it's 15 years?
Probably,
yeah. It's getting on a long time.
Yep.
I could actually say old friend. And, you know, we've done things together, some projects, but you've always got something new and exciting up your sleeve, and I just love learning about that stuff. Good. So, I guess today we're just going to ramble through a bunch of the new projects and clever stuff that you've been doing.
Sure.
Yeah. So just before we dive into it directly, tell me a little bit about Arvio Australia.
So Arvio Australia is based in Mitcham in Melbourne, and we have a small team of around 15 people, and we design and build software systems and energy storage systems and batteries. And we do it all out of our own warehouse, where we have a team of electricians and apprentices who do all the manufacturing. So it's built to a really good quality standard.
So you actually make your own battery?
Yeah, we build our own batteries because we wanted to build a battery that would last a very long time so that it could pay for itself many times over, and gave a very good rate of return when you look at it in a long-term sense. Obviously those things cost more money up front, but it's kind of like buying a Toyota Land Cruiser. You know, you buy it because you're going to keep it for 20 years, not because you want to get rid of it in 5. So we thought we'd design a battery and have a software platform that can manage and support the battery and then integrate other technologies.
I remember you telling me a bit about how you came up with the form factor, because you've worked with lead acid batteries way back.
Yeah.
How did you progress from that?
I figured just from a logical point of view, a lead acid battery case is strong enough to carry a very heavy battery. And for example, the battery cases we use can carry a battery up to 200 kilograms or up to 80 kilograms, 2 sizes. And our battery's net weight, when it's all packed in there, is only 43 kilograms. So straight away we knew that the case would be strong enough because it was half or almost half of the weight. Also because it's a lead acid battery type tub, it's waterproof up to the top, which is good if you're in an area where you've got a water risk.
Which is most of Australia these days.
These days, yes, as you've seen lately on TV. And then the large form factor battery we brought that in because of the large commercial jobs we were doing, where it was much easier to build one very large heavy battery that you just wheel in on a cart.
Yeah.
It weighs about 107 kilos, the bigger one, and which is quite easy to manage and hard to steal.
Yes, that's always a plus. I remember one of my students once saying, he was from Africa, we like this battery because it weighs 100 kilos, hard to steal.
There you go, exactly right.
And that was a lead acid. I think it was a salt battery actually, so
right.
You might remember those, but yeah, hard to steal and no valuable materials. That was the other thing, because lead's actually quite recyclable and
reusable for other things.
Other things, yeah. You can cash in on them. So tell me a bit more about this battery that you developed.
So we started developing it about 3 years ago, maybe a bit longer even, and we put one onto test cycling in July 2020. So that makes it's about 2 years and 2 months old now, and we stayed at cycling at 12 or 13 times per day, depending on the actual.
What sort of C rate's that?
It's 1C.
1C, wow.
Yeah. And the way I designed the battery was with enormous bus bars joining the cells together. And I thought the reason to do that is to minimize losses, and the less losses, the less heat, and obviously the less heat, the better for the aging of the battery. And but the side effect was that I built them so big that there's almost no heat coming out of the battery. There's almost no losses. So at 1C, we're registering around about 1% loss in each direction, energy going in, energy coming out. And at at C4, so charging over 4 hours, you almost can't see there's any losses at all because of the internal resistance of the whole battery as a whole.
So the most of the losses are thermal.
It's only thermal, yeah, and the thermal loss is insignificant because of the size of the conductors and the internal resistance of the cells themselves.
Yep.
So enormous fuses, enormous conductors, and everything's oversized.
Yeah.
And the side effect is the battery is very powerful, which means you can get a lot of energy in and a lot of energy out in a short period of time. The fuse is 800 amps on all of our modules. So if you buy say a 55 volt module at 800 amps, that's 40 or 50 kilowatts of peak DC power out of a 2.5 kilowatt hour module. So you can charge this module in like 10 minutes and run almost run a vehicle off it at 50 kilowatts.
So what sort of cell can you charge at that rate?
The chemistry is called LTO, which is lithium titanate oxide. And it's kind of in the supercapacitor family if you look up the different families of supercapacitors.
You told me this, so I went and did it. And there it is on Wikipedia. There's like, I think 8 categories?
There's 8 different categories. There's pure capacitors, which are the pure
charge storage,
electrostatic,
yeah.
And which have extremely high power, even more power than our battery, and then no electrochemical storage. And then there's the hybrid cells, which they behave like a capacitor, they age like a capacitor, they give peak power like a capacitor, but they also have electrochemical storage.
Actually, I've got a cell here. Comparison.
Yeah, that's the that's a 100 watt hour cell, and very harmless, 2.5 volts DC. And so within our battery modules, we pack them in different combinations. So we picked 24 as the multiplier because 24 has got lots of divisions.
Yes.
You can do a 24 cell in series, which gives you 55 volts.
It's kind of why the imperial system is base 12.
Oh, right. Is that why?
It's got the most factors for a small number.
Oh, there you go. Yep.
1, 2, 3, 4, 6, 12. Yeah, a lot of factors.
So you can have 55 volt, 27 volt, 13.8 volt, 18.4 volt if you want. So we make all different size, different voltage outcomes for different purposes.
So this is lithium titanate or LTO.
LTO, yeah.
And I just for comparison, this is a lithium ferrophosphate. Yeah. So this is, I think, 3.2 volts nominal.
Yeah.
This is a 100 amp hour cell.
Yeah. But
it's only really rated at charging at 0.5 C.
Right.
Discharging at 1 C.
Okay.
This can charge at what?
6 minutes. From
wow.
empty, so 10 C.
10 C.
Yeah. But we think that probably keeping it at 4C probably is a nice thing.
Yeah.
15 minutes.
Because then it is the thermal. These conductors will start to heat up because that's a lot of amps.
It is a lot of amps, yeah, and which is why we have such large. So the bus bars on the sides of our modules they're 10 millimeters thick aluminium, and they're 60, 80 millimeters wide.
Yes.
And it's a lot of conductor cross sectional area.
So you combine these to create a 2 volt cell.
No, our smallest one's 6.9 volts.
6.9. Yep.
6.9, 9.2.
Yep.
13.8, 18.4, 27.6 and 55.2.
Wow, all in the same form factor, you just change the series parallel configuration.
Yeah, exactly. And the 55.2 we can give it in smaller voltages too by taking cells out.
Right.
So for mobile phone towers, they want it to be no more than 58 volts when they're fully charged to suit their other equipment. So we took one cell out and made it a 23 cell module.
And how heavy are these?
43 kilos.
Right, so quite manageable.
Yeah.
I often ask that because I'm the person who has to move these things here.
Yeah.
If I can put it on a trolley and easily move it. But when it gets to 100 kilos, it's a bit of a pain.
Well, the large one's 100 kilos. It's 107 kilos, and that's 6.2 kilowatt hours.
All right, well, we'll get a proper lifter for that.
Yeah. So we've installed them in all kinds of projects around the country. We started exporting about 6 months ago.
Yep.
And the client overseas has started to place some very large orders because they wanted a battery that could work at negative temperatures. So these cells are rated down to negative 50.
Wow.
So that makes a big difference when you've got a problem where, if your heating system fails and you've got a battery there that's supporting something and then the battery goes below zero. If the battery's warranty fails under zero, then you've got a problem. So with our warranty doesn't fail under zero, it fails under negative 50.
Right.
If it's negative 50, they've got other problems.
Yeah, like all the rest of the equipment.
Yeah, everyone's dead. So.
It's just coincidence. I was actually doing some consulting for the Antarctic division on a battery system, and I thought cold would be the problem, but they actually put them in controlled thermal spaces for all the other equipment. It's actually the battery is a benefits from being inside a thermally controlled cabinet, basically a weather station, in the middle of nowhere.
Yeah.
But it's the humidity that's the problem. It's so low that static electricity is a problem.
Wow.
Yeah, so
Interesting.
not a problem for batteries, but it's a problem for sensitive electronics.
Yeah, one other problem they have down there is if the room isn't insulated well enough against the footings get warm and it melts the ice that they're sitting on.
It starts to sink.
Yeah.
Where's it gone? It was here last time we looked.
Yeah, it's very interesting. So I love all that the thermal side of it. I think it's very interesting.
So going back to the cycling, you from 2020 you cycled it 13 times a day.
It's still cycling now. I can log in and show you. Would you like to see it?
Yeah.
All right.
Cool.
I'll pull that up on screen.
How many cycles is that?
It's up to almost, I think it's done 10,000 cycles now.
All right, wow. So, many batteries, certainly lithium ferrophosphates, they generally rate them for about 4,000 to 6,000 cycles. And you've already done 10,000 cycles with one of these.
Yeah, and guess how much degradation it's had?
I don't know, 10%?
It's gone up by 2%. It's a magic battery.
It's a magic battery.
And it's all here. I can actually give you a login right now and you can go home and you can study every cycle and write it down with a pen and paper and convince yourself. So if you go, this is right now, okay?
Yeah.
This is yesterday. I just chose yesterday.
Yes.
I'll just zoom in a little bit. You can see here that by the time we got to the end of yesterday, we'd put, at the change of cycle here, which is just here, we'd put 22.5 kilowatt hours in and we'd extracted 21.287 kilowatt hours out of it's a 2 kilowatt hour module. A 2.2, so we're just cycling it to about 90% because when you're charging so fast, you can't charge right up to the top, obviously, because it's got to equalize.
Mm-hmm.
So we just charge at about 1 hour rate, hold it there for about 5 minutes and then turn it around again.
For those who are not familiar with how you manage a lithium battery, or any battery really, why do you have to change the charging rate at, say, 90%?
Because no cell's perfect, and one cell will reach full before another, and because of that, you don't want to charge that cell anymore because they'll all come up at the same time. They're all in series. So what we do is we detect that in our software that any cell, when it reaches 2.7 volts, then we assert the inverter to come back to a 2 amp rate of charge. So we just charge flat out until it reaches, any cell goes 2.7, which it got high first, then everything else has to go slower.
Oh, okay, so it catches up. So as soon as it detects imbalance, or topping out, really.
Topping out on any cell.
On any cell, it slows down. All right, so it's actually, if you are doing something like a service like FCAS, frequency controlled ancillary services, you probably want to move it in that 20 to 90% range.
Yeah, exactly.
Yeah.
I'll show you actually some clever stuff on FCAS later on. You have to make sure you bring that up again, right?
Okay, cool.
So here's yesterday, and then we can go back like a previous week here. And then there's a week of cycling. Mm-hmm. So it's 12 times per day, and then we go back a month, and it starts to get too impossible to see because that's just a blur now. But you can go all the way back to back to the start of time. The dawn of time.
The dawn of time.
Which is July.
Isn't that 1970, the 1st of January 1970?
Something
That's
like
the dawn of computer time?
Okay. So
I'll put a correction in the comments if I'm wrong.
So here's a day back then.
Yep.
And in that day, same, 23.78 kilowatt hours in, 22 kilowatt hours out.
Right, so almost no capacity fade.
No, it's gone up.
Gone up.
So I actually I took all these data sets down and actually created a database of testing data, and I looked at it over a sample rate every 2 months or so across the whole period.
Yep.
And it's just flat lines and it goes up. Some months it's a little bit higher because of the inaccuracy of what you call a day.
Yes.
Because a day this doesn't know it's a day, it just stops, it starts partway through midnight here. So.
Now, I might be making this up, but I know with lead acid batteries there's a formation period. So when they put the acid in, it takes about some months and some cycles before the battery reaches its full capacity. I wonder if something similar is happening with
Maybe,
these.
yeah, it's like breaking an engine in your car.
Yeah.
So here's all the cells here.
When did we last do that?
Yeah,
drive
true.
at like 25k for 100k.
You see here's all the cell data here.
Yeah.
So every cell's monitored for the whole life of the product.
So is this like special monitoring you have just for your R&D department?
No, this is all accessible to everybody.
Wow.
So when you buy a system, when you buy our batteries and our software platform comes with it,
yep.
the dashboard system's included. This is our previous dashboard system. This was developed by my great friend EJOS. He passed away about a year and a half ago now. And my other good friend Adam took over the software about 3 years ago and sort of helped while EJOS was unwell. And so we named the new platform EJOS after him.
That's lovely.
Yeah.
He lives on.
He lives on. So, but the new platform is taken all the great stuff that EJOS did and then added to it and answered all the questions we couldn't do before, which is multi-technology rules. So you can write your own rules within the portal.
So this is not just monitoring.
No, it's actually a control system.
Right.
Yeah. So let me show you that. So that's the answer to the cell anyway. You can see the cells cycling. We know they don't degrade. We've got thousands of them out there now cycling, and we know they're all the same. They're all giving the same outcome where they're not degrading at all.
So this, like you said, is the earlier platform EMAX.
Yes.
And the new one's EJOS.
Yeah.
EJOS. I got to get it right.
Yeah.
Does it integrate with other platforms like SCADA, etc.? Can you import
easily?
Easily.
Yeah. And I'll show you how.
Because I often get that question from CNI customers, certainly government entities.
I'll just quickly show you a photo of the batteries because you weren't interested before about the batteries. So there's some form factor there. So this one here is a 6.2 kilowatt hour module in 13.8 volts.
Oh, I remember this with all those disco lights on top. Look, I'll link it up here in the card, but I actually made a video about this when it was being built. I think it was probably a similar one.
Or? It might be a different one.
Might be, but it was basically the same form factors.
Yeah.
And when you turn off the room lights, it's pretty magic in there. It's got to get the tunes going.
That's right. So this one here is 13.8 volts, 10 in series to give us 138 volt nominal. And it's an 800 amp bus. So it's 800 amps by 138 volts, which is whatever that works out to be, 100 kilowatts or so. And there are two strings and they're paralleled. And they're paralleled in this little thing called a bus duct, which is like a combiner.
Yes, I know. You had solved some challenges with the fact there's such enormous fault currents.
Yes, by creating so much current, you get all these great advantages, which means you can do a lot with it, but you also have to deal with the safety.
Yeah.
So
you showed me a little phone video of testing one of your systems.
Yes,
it was rather loud from memory.
Oh, I can play that back to you at some point, but that's where we actually we short circuit tested it at 50,000 amps at 800 volts.
Whoa!
And to see what would happen if you shorted out the connectors, and they naturally exploded. But then we tried it with the fusing, and the fuses just failed perfectly. So we proved what would happen if you didn't do it properly.
Yes. So you mean the fault potential was 50,000 amps without the fuse?
Yeah, 50,000 amps with 800 volts.
Yep.
And that was with fuse and without fuse. We tested both ways.
Wow.
So the fuse is rated to take that.
Yes.
So we're proving that the fuse could do its job and provide safety. And so that's what we did with the testing.
These batteries can be used in relatively high voltage applications?
Yeah, you can series connect. The highest we've gone to is 800 volts so far.
Right, okay. Wow.
We can probably go higher. We just need to get a different fuse and just consider a few other things around isolation.
Now coming back to the BMS, I know we really talked much about the BMS, but you developed your own or integrated with a third party or something?
Yeah, a bit of both. We build half the circuit boards ourselves, more than half, and the other half we buy from a manufacturer. So they've got pure supercapacitors on the boards, and they actually import the energy from the high voltage cell and then hold it and then put it into the low voltage cell. They're just continually shuffling energy around.
Oh, that's the balancing circuit.
Yeah, we have two balancing systems. So for redundancy.
So there's a supercapacitor and the supercapacitor.
Exactly. A pure supercapacitor in the not so pure supercapacitor. So
that's a very clever way. So it's a lossless balancing.
It is. It runs on 1 watt.
Wow.
So and there's almost no loss in the actual transfer because it's going into a pure capacitor.
Yeah.
So we have almost no losses in anything, which is the whole idea was how do you get rid of all the losses? Then you get rid of heat, you get rid of degradation, and you don't have so much aging of the components and so on.
Yeah.
So but we also have what we call the noisy balancer, which is it creates an AC 2.5 volt bus between all of the cells, and then there's a balancing chip which pushes and pulls energy from that AC bus depending on whether it thinks it's high or low based on the frequency it can hear in the bus.
Oh wow.
So it sits at about 2 kilohertz.
Yeah.
And if it hears 2 kilohertz, it says, well, if I was making 2 kilohertz, then I would be higher than these guys. So therefore I'll export to the bus. And if I was making less, I'd import from it. So they all try and be the same.
So the frequency is a reference that they compare themselves against. And
the higher the frequency, the higher the voltage. And they go, am I above that or below it? I'll push or pull.
Wow.
And that way they can all do it concurrently.
Yes.
Because they're all on the same bus.
So it's not really noisy. It's only electronically.
Yeah, you can actually hear it.
Yeah?
Yeah, you can hear the
2.5 kilohertz is a
Yeah. It's like a little mouse. My kids hate it. But I can hardly hear it. So.
Yeah. Well, inverters also, kids don't like them because they're like 18 kilohertz.
Yep. And so we have both balancing systems on there. So if there was ever a problem with the noisy balancer not doing its job, it's a hardware balancer.
Yeah.
We can see it.
Yep.
And then we can also do things, take action based on that.
So your kids don't like it. That means they've got a battery in their bedroom or something.
You can only hear when the lid's off, really.
Okay.
When the lid's on. But if you put a lot of batteries together, you
Yep.
can actually hear them. It's quite a pleasant sound. That means you know they're working anyway.
Yeah, anthropomorphic. You know, it's alive.
Yes.
Yeah.
So I'll show you the new site,
Mhm.
which is just here. And I've obfuscated the names of the sites.
Okay.
So my
Just made up some-
software guy just put some code in there to
Oh my gosh.
encrypt everyone. Okay, so these are actually real sites.
Looks like targets in Ukraine.
Yeah, something like that. So I'll pull up a first site. This one here is our site, which is our company.
Yep.
And in here we've integrated SP Pro inverters, which I'm a great fan of electronics inverters. And I've also integrated Fronius directly. So
Yep.
you can go directly through Modbus over IP. So if you didn't have comms to the Fronius via SP Pro, you can do it via the Modbus. Here I've got an EV charger by Ocular. They make quite good quality EV chargers. And here we've just we've integrated the EV charger using the Modbus over Ethernet. Over here we've got frequency monitoring. Now you asked about FCAS before. So I just started this testing just the other day. So I'll take you through what we did.
So this is grid frequency you're monitoring?
Yeah, this is grid frequency just through the SP Pro.
Yep.
To 2 decimal places. And this is the last 6 hours. You can go back a longer period if you want to, last day. You can see it jumping around everywhere.
So what's the limit on those axes? How much frequency shift we see?
The lowest one's got 49.94 hertz there. So that was an FCAS event there.
All right.
Okay, so if we go now to messages, you'll see the message triggers here. Okay, so I set the window of tolerance to 49.99 and 50.01 hertz as the threshold because
Yep.
I wasn't getting enough alarms to see anything.
Yeah, you're right.
So I set the window narrower to see it changing all the time, so I knew the rule was working.
Yep.
And then I just put it back to normal again.
Right. So you could then just use that to play in the FCAS market based on the settings that
Yeah.
AEMO provide you with.
Precisely.
Wow.
And so the way you do that, firstly what you do, so I'll just go back to the dashboard again here. So each of these graphs here is freely configurable in size and where you get the data from.
Mm-hmm.
So let's say you've integrated a brand of inverter that isn't symmetrical with, it doesn't coordinate with SP Pro, for example.
Mm-hmm.
You could, in theory, ramp it down and ramp it up based on a rule, based on the SP Pro sending out a signal. So you could be controlling another generic inverter off an SP Pro.
Right. So with FCAS, you want to be able to respond to a call
Yep.
for either charging or discharging a battery. And so you're basically telling the inverter,
Yes,
export at X for
Yep.
until I say stop.
exactly right.
Yeah.
So here we've got cell levels being monitored here. We've got here the data from the actual small device. This is what it looks like. It's just a single board PC. It runs Linux.
Wow.
And
That's cute.
we chose that one because it's got a nice heat
It
sink.
has a massive heat
It's a
sink.
good size. The battery's on the front and the eMMC squared chip goes on the front as well. So you can see everything from the front.
Wow.
So yeah, it's just a little bit more advanced than a Raspberry Pi.
Yeah, yeah. And it's got a full-size HDMI, which is nice.
Yeah.
That's what I like about my Pi 4s is the tiny micro HDMIs.
Okay.
Yeah.
And so looking at that, that's the system information down there, the memory and so on. So we can see if we develop new code and deploy it, we can actually see if it ran away and had a problem.
Yep.
So going up to here, if I want to add more information on my graph here, I can put up a full screen graph here, like that.
So hey, just coming back to this product, you only need one of these per site.
One per site.
Yeah, so it's not every battery. And it's communicating with all of those devices.
Correct.
Through what, Modbus, TCP?
I'll show you.
Okay.
So if you look in here, we'll go to the right column first, okay? So state. So state is showing me all of the current connected devices. So on the left I've got here the Modbus EV charger. I've got the SP Pro's main information. Then I've got each of the inverter phases. Okay. Then I've got, so basically you can get every bit of data, you can see it all in the right column. That's how often it was refreshed. So then you know you've got everything. So rather than scrolling through everything, you can just filter and say, I want SP Pro, and I want
Can you make it a little bit bigger for my poor eyes?
current.
That's better.
Okay.
Yeah, good.
So I just filtered by the name and then by current, and that shows me all the values of current that the system is discovering. Okay, and it tells you the raw data coming out of the inverter right now.
Right.
Okay, so that just helps you understand that you got your integration right.
Aha.
So to make an integration, you go to configuration up here,
So this is a generic inverter, for instance.
Yeah, so you want to bring another inverter in via, say, Modbus
Yep.
over Ethernet, which a lot of them have now, or
Yep.
Modbus over RTU,
Yep.
which is just a standard USB cable, which
Yep.
we sell.
Quite familiar with that.
It's got a little A and B wire here and a
Yep.
ground. And so you just plug that into the device here, and then plug that into your generic inverter. And you go up to configuration up here and you say add. What type of device you want to add? A Modbus device. What am I going to call it? I'll call it an SMA inverter, let's say, 5 kilowatt. And I want to communicate Modbus via serial. And the host script is one that you can extract from the USB stick when you plug it in, because any brand of USB stick needs to be communicated with by this PC. So we sell this particular one because we've tested it and written a script inside here. So to make that check, all you do is go over to administration, diagnostics, plug in your device, and you just type in a special command, which is...
You mean it's going to sniff the connection?
Yeah, it does.
Oh,
Energy system that I want to look at. I want to look at, say, this one here, and I want to look at submit. And there you go, it just found this device on here, SP
oh
Pro.
okay. Yep.
So I can just copy and paste that and put that into my configuration.
Right. So it's just looked at the system logs, found that a device called Arvio SP Pro, long number,
Yeah.
has been connected.
And that's the serial number of the SP Pro there.
Yep. And then you put that into...
So you go back to the sites here, go back to your system site here,
Yep.
configuration, add your system on here. So you can have two windows open doing that. You can just split the screen.
So a user can do this,
You can-
an end
yeah.
user. So
A reasonably competent installer would be a better way to put it. But,
yeah.
But a user can do it. So you can go and buy an EV charger with Modbus over IP, and you can integrate it yourself.
Wow. That's so cool, because I'm used to integration being something you'd have to wait for the company who sold the product to do for you, and you go, please
help me
integrate
out.
our new
Yeah.
thing.
And so if I want to add in that Modbus device here,
Yep.
I'll go Modbus, and I'll go back to here again. We'll call it SP Pro. And in fact, I've got already built integration here for SP Pro. It's already customized.
Yep.
But if I do Modbus, I'll call it SMA. I'll pretend that one was SMA, and it was over serial because it was one of those cables. The host address is here, and you put in the script there. Give it a baud rate that it wants to run on.
So this has 4 USB ports, so that it could be 4...
No, but you can have as many as you want. You can do a USB hub.
Oh, you can do a hub and then...
Yeah.
Yes.
And it actually finds them, it calls it, say, port 1, it'll be 1.1.
Yeah, right.
1.2, 1.3,
Yeah,
or
hub
3.1, 3.2.
Gotcha.
Okay, so you can have as many as you like.
Wow.
And
So I've got, I think, probably 20 plus inverters on the wall here. Of
you can bring them all into the same dashboard.
Really?
And then you can plot them all on
Wow.
the same screen. So all your energy systems can be on the same screen, all your power, your voltages.
Paul, I'm getting kind of all tingly.
Yeah, it's very flexible. So then you add a mapping. So once you've found the device, when you buy a product that has Modbus,
Yep.
it'll give you a Modbus map, which
Yep.
says on line 105 you'll find voltage, on line 106 you'll find energy.
Yep.
So you just go in here and add mapping,
Yep.
give it a name, you might call it voltage, can't spell, and then type. So there's 4 types of data connection with Modbus.
Though some Modbus maps are proprietary.
They are, and we do customize if somebody needs it done, and we've had to do that for ourselves.
Oh, okay.
We bought something that was supposed to be Modbus and it wasn't Modbus.
Right.
It was just serial RS485 and it had a map and it kind of worked, but we had to do something special.
Gotcha. Yeah.
So you can ask for a special customization. It might just come at a cost.
Okay.
So here you've got coil, discrete input, holding register, and input. So you can see what they are: read, write, true, false, read only, true, false, read, write number, read only number. And that'll be on the map that you got from the manufacturer. And then you give it the start address, which is line 1001, let's say, and it might be data type 16-bit, which will tell you on the manual as well. Whether you want to multiply the number by a factor, so it might be milliamps instead of amps, or volts
Right.
instead of kilovolts, or whatever you want to have.
Yep.
And then add the calculation, and then press OK. And now that's mapped. I press save, and now I've mapped that device via serial to that inverter on that line number.
Yeah.
Now that'll appear now in state. So if I did save that, I won't.
Yep.
Then in state here, you can just filter by that device and say, well, for example, the Modbus ocular device, OC2 we've called it. There they are. There's the 3 line numbers, and there's the value they're getting from each of the 3 phases. So you know that your integration worked. That's to test.
It's the test.
If it doesn't come up there, then you didn't get something right. You got the baud rate wrong, or you didn't plug in the right port.
Okay.
Something happened. So once you've done that, you can go to rules. You asked about FCAS before.
Yes.
So I wrote an FCAS rule yesterday on Friday last week. with Adam, my programmer. And here, FCAS 60-second market, the rule is this. This is JavaScript. Now, if you can't write JavaScript, no, I can't write JavaScript, I'm trying to learn, but let's just say I could write it, or I can do it myself. If I can't write it, you can just create a new rule. Let's go back to rules here. Create rule, and I'm going to call it Glenn's AC control and inverter combiner. Okay, you call it whatever you like. And you just delete all that script. That's just an example, and write, if my inverter makes
Natural language.
more than 100 watts, then turn on the AC. And then all you do is inactivate the rule and save it and send us an email.
Oh, I see. So you describe what you want the programmer to write for you in
Yeah.
JavaScript.
Exactly.
Oh.
And then that takes 5 minutes for the programmer just to reinterpret anything.
Yep.
You've already checked that you've integrated the device and that it's available in state.
Right.
So you say, if this value here equals that.
Yep.
And what's clever about it is when you're actually writing the formula, you create rule here. If you click on this line here, it actually searches for values you can get to. If I start typing SP Pro, it finds all of the available values that are in the state.
Right.
So you're kind of not having to type the whole
Yep.
address in of the device.
Yep.
So you might want to find, if I have a firmware version of this, then send an email to Lindsay Hart saying I've got a dodgy old software. Something like that.
Apologies, Lindsay.
Okay, so you can
coming back
write
to
your own rules in there.
the FCAS rule.
Okay, let's go back to the FCAS rule. So you were
just given that some of our audience won't be very familiar with this process, so
do you want me to explain
let's
it?
go real basic. What is FCAS?
FCAS stands for Frequency Controlled Ancillary Service.
Yep.
And what that means is, in the event that the grid's frequency, which is consistent in Australia down the eastern seaboard from Cairns, I guess, to Hobart, the frequency is the same generally all the time because all of the grids are connected. And so if the frequency starts to fall, it means the grid must be under load,
Yeah.
which means that the people are drawing more energy than the whole system can generate. So the flywheel starts slowing down, which
Yeah.
means the frequency starts going smaller.
Yeah.
And then so we say, what's the natural reaction to that? Spin the wind turbines faster. Well, you can't do that. Put some more coal in the fire. Well, it takes too long.
Yeah.
Maybe get a battery to export. Oh, good idea. That'll work. Maybe turn off some loads. So back off all of the air conditioners in Hobart because that will actually create a frequency jump.
Why are you picking on Tassie?
Okay. Well, Tassie's the other end of the cycle. Okay. So that's what FCAS is, and there's 3 markets, I think, maybe even a 4th now. There's a 6-second market, a 60-second market, and a 5-minute market.
Mm-hmm.
And each of those markets pay interested parties who are part of the system. So a market participant would subscribe and say, I want to have a 1 megawatt battery on the grid, and I'll provide this service of pushing and pulling energy from the grid on command when I see the frequency change, and I want to be paid for that service. And that's what FCAS is. So you basically bid in to AEMO and you say, I will offer you this service. I'm already a registered generator with you, and I want to be paid for providing the service of helping the grid be stable. And so this rule does it for you from a standard inverter.
So it sounds like it's only for big players.
No, you can be an aggregator and aggregate lots of small systems. So I could go out to all of my SP Pro clients and log into their systems, upload this code, and then make a virtual battery out of it all and not even tell them.
But you wouldn't.
No, I wouldn't do it, of course. Of course I wouldn't do it. But the point is that you don't actually get paid for energy, you get paid for power.
Yeah.
Because power is what is useful, not
Yeah.
energy. So the customer doesn't really see any change in their bill because it's only happening for 6 seconds.
Oh my gosh. Yeah, right. It's just little blips.
It's a little blips. So
Yeah.
and if you said, you know what, if you let me use your battery, I'll give you a lifetime warranty on your battery. Would you like that? Oh, fine. Just use it whenever you feel like it.
Right.
So
Wow.
that brings me back to our warranty is 10 years.
Yep.
And we also have a 20-year option.
Yep.
It's in a maintenance contract. Because we've now cycled it for effectively 25 years, so 10,000 cycles is effectively 25 years.
Yeah.
So we're quite confident that it won't degrade because we've tested it. So going back to this frequency control service, this rule here we wrote basically says if the frequency of the inverter says this and the inverter is turned on to frequency mode, so in integrations here, the integrations tab, if I turn this relay on and off, that turns it on and off. So I look at that switch, and if I see the switch in the off position, I won't run the FCAS rule. If I see it in the on position, I will run the rule. Okay, this is actually like the control interface of the SP Pro as well. You can turn the priorities off and on, and turn the schedules off and on.
Oh, so you effectively interfaced with SP Link.
No, integrating directly into the SP Pro.
Oh, right, okay.
So you can control all your SP Pro inverters.
So in SP Link, you'll set up the priorities, but then you can turn them on and off in this interface.
You can do them manually here to prove that they work.
Yeah.
And then you can go into the rules and you can create a rule that does it automatically based on something.
Yeah.
So you might say in the event that the frequency changes, then export the battery power or import the battery power, or go off grid. Or if there's too much PV and the Fronius inverter started to ramp down, then turn the air conditioning on.
Yeah.
So you can start to be clever about how you...
I'm just going to do a explainer. On what we're talking about here, in terms of priorities on the SP Pro, which is one of its really strong features, is if you particularly, say, a grid interactive, you might have conditions like the power's cheap at a certain time of day, or you want to start a generator at a certain time of day because you're off grid, etc. You can set priorities and stack them. So there'd be one which is, number 8 is basically just be on all the time.
Yep.
And then you can stack ones on top of that which are very conditional. And there's so many parameters that you can set.
Well, I'll jump in here and show you what you said. So this is...
Are we recording this still?
Yeah, it's all recording.
Good.
Yeah. So within the EJOS device, you don't just get monitoring and control and multi-technology, you also get programming through it. So you get a portal that lets you reprogram the SP Pro remotely.
Yes, because the Emacs did that for you.
Yeah.
So you've taken that feature and added it to the EOS.
Yeah, and you can do it with any other technology as well. You might have another device that needs to be programmed remotely that is stubborn or uncooperative or hard to program.
Yep.
And then you can say, well, if we had this for this device...
Gee, I've got plenty of those.
Yeah.
So, you wouldn't believe how bad some of the software is on inverters.
Yeah, exactly, yeah. And you can actually make it better.
Right.
So if you go up to File Site Information up here, it says here, so when you run a little plugin that we give you, in the background, the next time you open SP Link, it actually adds this new Emacs connection up the top here.
Yeah, right.
Okay. And so in here, you just give it a site name, what do you want to call it? And then it lists all the sites you can get to. So if I just jump onto this one here.
So this is online. You're
doing
this live.
Yeah.
Right.
So you don't have to go and find the customer's email address and password, which other programs I think do.
Mm-hmm.
This one, you just get a whole list of all the ones that are under your name.
Right.
And there's a hierarchy of access as well. So you've got installer access, and you've got user access and guest access and administrator access. So you could be the boss of the company and let this installer get access to these 3 sites and this one to get to those 3 sites, but you can get to all of them.
So does the customer need select.live?
No.
They don't. So this is effectively replaces that.
Select Live, yeah.
Right.
And it's basically Internet of Things, Select Live combined with Emacs combined with every other device.
Wow.
So,
yeah.
And it's $500.
Wow.
So for the value for money point of view, you get a lot more out of it than you would from another device. And logically, you think about it, if you buy a remote access portal from a manufacturer of a product, they don't really have a need or an interest to integrate it with all the other brands of gear. They don't want you to do that.
Yeah, right.
So we look at it from a third-party point of view. Well, what's the best thing for the customer? Well, it's to integrate with all this really good technology. That's how we do it. So in here, you were talking about configurations before, which is under priorities here. So you've got priorities you can turn on and off here. This is an off-grid site, so there's not much to turn on and off in priorities. They only work if they're on-grid.
That's right.
So I'll jump out of that now. So that's the connection method.
It's pretty fast.
Yeah, it's very fast. So we run it all through Microsoft Azure. So it's running through the cloud on the closest servers.
Yep.
And we have unlimited bandwidth really. So if we find it's getting a little bit slow, we just increase our connection speed.
Yeah.
We can migrate it to other countries and make it compliant. So for example, in Europe and in the US, you're not allowed to host private information about people in your country if it belongs to US citizens.
Yep.
So you need to host it there.
Okay.
So we can migrate the system into a California Azure session just by ticking a box.
Right.
Okay, so in here you've got all these controls. Now, with our battery management system, we've got quite a few functions where we have like a hardware level cell monitoring as well as software. So we look at the cells and we say, does any cell get over 2.7 volts? If it does, then close contact. At the same time, we're monitoring through software to control and ramp things down, but if something happened with the software, we've got a failover with the hardware.
Yep.
So on a site we did recently up in the north, the control board has got a digital out for high cell and a digital out for low cell, so we connect them into the digital in for the SP Pro for input 1 and input 2. Now I want to test this from here though. How do I test that my device up there is actually going to talk to that, and they've got the wires the right way around. So what you can do is you can actually open up the screen twice. So if you duplicate the screen here, bring it over to new window, bring it over here to the right side, it does split screen. Okay, so now I've got the same screen twice. So I'm going to go over to integrations WESP. This is my control board, diagnostics.
So this is so you can see input on one side and output on the other.
Precisely.
All right.
So here I can actually simulate signal 1.
Yep.
And then I can go to state over here.
Let's see if
and
it
I can
changes.
look for digital in.
Yep.
Digital in. And they say false down the right side there. So if I turn on signal 1, I don't know if this site's actually set up to do this. Probably is. It takes a little bit of time. You've got to refresh the screen here. There you go. True.
Hey.
So I got it. I know. Now I know signal 1 does do what it says.
Right.
And then within the SP Link software, then I tell it, what do I do if I get digital 1 in?
Yep.
What's my instruction?
Yeah, sell.
So buy. Okay, so that's an example of integrating 2 bits of hardware on the same dashboard and testing them.
Yeah.
So you can change the LED color on the BMS board to a different color. So if you've got lots of them, you can find them easily. So your technician, go to the one that's magenta, It's magenta, go and find that. And then he goes, I can see it now, I'll go to that one.
Oh, on the battery?
Yeah.
Right, yes.
So you help the technician out to find it.
Yeah, the locate functions are
Colour.
really useful. Yeah.
So you can reset the LED here, you can power cycle the battery management boards, you can fire a circuit breaker.
This would be great, what people sometimes refer to as remote hands. So you've got, the engineer in their office, you've got a service staff on site, and you're working together on solving some problems or configuring and installing a system.
Yep.
It doesn't matter that you're not in the local.
Exactly.
Yeah, wow. That's so cool.
So I think about that's still on true, have I? I should go back in there and take it out of true, shouldn't I?
They're selling all their power now.
Signal off.
Let's turn the lights off.
Yeah. Okay, so that's an example of 2 technologies working together.
Yeah.
So going back to your FCAS example, you can configure it in rules here. This rule here we wrote. You can write as many rules as you want. You can make them as complicated as you want, or you can have one rule here and then another rule is another rule. Or you can make a very long rule. It could be 50 pages long if you want to type it out. Can
I come up with a very selfish rule for me, which would be, because we're on a frequency-controlled microgrid here,
yes.
And there's lots of different brands of inverters and battery systems, I'd love to be able to soak up surplus generation across all of those different systems, but at the moment only one of them, the microgrid controlled system, will charge up, raise the frequency, and everything else will just turn off. Okay. But I'd prefer they went and charged their batteries rather than disconnect.
You can automate that.
Wow.
So you can start to solve all these problems that were too difficult to solve before.
So effectively turning lots of systems into one virtual battery.
Yeah, and different brands as well.
And different brands.
Yeah.
Now that's a big plus.
And then if something else comes along that you want to add that doesn't even exist yet, like an EV charger didn't really exist 10 years ago, now it does.
Yep.
Then as long as it's got some kind of comms, whether it's serial RS485 or Modbus RS485 or something else.
Yeah, so we've got the SMAPI system here, and that's got comms.
Same sort of thing?
Yep. Yeah. It's got CTs to measure input from the grid and consumption to the loads.
Also, we did one the other day for a site which was, we wanted to measure a generator's performance over time.
Mm-hmm.
So these are all encrypted at the moment, so here we go, this is it here. So we just put 3 current clamps around the 3 phases, and we fed it into a Wago, which is a electronics terminals brand, a really good brand from Germany. And it had Modbus over RTU, over serial. So we took this cable, we integrated it. We hadn't even finished developing the software yet. We deployed it to site. My software guy logged in, Adam logged in and wrote some code in here and added that device in through that portal.
Wow.
And so now we monitor the generator and we can see how much energy and power the system's using over time. You can click on this little button up here, which is synchronize the axes here, and it shows you the same. You've got energy per phase here from one device, and we also plot the weather data, so you can go into open weather and you can do a binding with the weather site, and then it gets up to 1,000 calls per day with all the weather metrics, UV and everything. So you can then look at UV. If there's UV and there's not PV, then you've got a problem.
Oh, okay.
And you can write a rule.
You don't actually need a radiance meter. You just need to know
what the UV is supposed to be at that suburb.
Yeah, right. Oh, okay.
So you could write a rule that says if there's UV and there's no PV generation, then do something.
Sad face. Yeah.
Sad face, yeah. Send a message, okay? So the messages system here, you can push to an app, which is a messaging app.
Yes.
So you can download an app on your phone which has got free number of calls, and it creates a little API key.
Yes.
And you can put the API key in the message in the rule, and then when that event happens, it sends you a blip on your phone.
I'm really genuinely getting very excited because I love to tinker with stuff, but often I have to rely on asking another party to do something
work for
me.
you, which costs a lot of money. And,
Yeah.
And if you learn this and you get good, like I've had to learn it because I don't write JavaScript, so I've had to work out. Well, at least I can modify JavaScript. Now I can't write it yet, but the JavaScript person just writes it like they're typing a Word document, so it's not hard for them. And then once you've written the rule in here, let's say you create a rule. Here's an example rule.
But I was thinking just the integration was so simple.
Yeah, it is. Yeah.
You know, literally plugging it in, finding out what device it was.
Well, it can be on the Ethernet on the LAN,
Yep.
or it can be on USB.
So on the LAN, you're doing Modbus TCP.
Yes.
Yeah, and so you would need to know the IP address of the device and
correct.
Yeah,
Yep.
and port number
and you can reserve that in the router. So
Yep.
if you've got a dynamically assigned device that always gets its IP from the router, you
Yep.
can go into the router and say, if you see this MAC address again, always give it .15.
Yeah, fixed
Once
IP.
you've done that, it's
Yep.
really got a fixed IP.
Yep.
And then you go into your configuration here and you go add the device, Modbus device, give it a name, EV charger.
You could even scan for MAC
TCP.
address.
Yeah, well you could. 192.168.1.5, whatever it's going to be.
Yep.
The port number is normally 502 for Modbus. What type of engine this is? This is a funky name for how it talks on the data, which is on the Modbus map information you get from the manufacturer. Concurrency key is an interesting thing. So we wrote this recently so that if you have multiple devices talking on the same serial cable, you don't want to have them clash because they're all sharing the same speed. And so what it does is if you put the key in here which says Glenn, and I go to my other rule and put Glenn in there, those rules will never run at the same time.
Right.
So if you run the rule, then it waits, and it waits half a second or a second, then it runs its rule. So it never overlaps the rule. It's quite useful. We found that out by mistake.
Right.
That we needed that.
This is where you're sharing a Modbus data line with multiple devices.
Yeah, so this could be sharing an SMA inverter and another inverter.
Yeah,
another inverter, as long as you're on the same baud rate.
Basically daisy chain.
Daisy chain across all the different devices with one cable.
Yeah, right.
And you might want to call on them different times.
Oh, cool.
So you could buy lots of these and do one to each device, or you could buy one and do many. It depends on the baud rate and the method of communications.
Yep.
And how much data you want to get across. Because obviously if you have your own cable dedicated, you get high speed. If you don't need high speed, then maybe it's better just to have one cable.
Right. Paul, we've covered a lot of territory. Did you want to sort of give us a little wrap at the end here?
Sure. Okay. Well, basically, we would recommend everyone buys our batteries because they last. Well, I could say forever, but it's probably not true. They last a very long time, and we've proven it. And they're very safe, so they don't have a fire risk, they don't have a thermal runaway risk, and they have very wide temperature operating band. So that makes them useful in hot climates, cold climates, and for anybody who's got a long-term strategy. If you're looking at running a site for a long time and you want high reliability, we monitor every cell, we put high reliability cells in our modules, and we build them locally. So you end up with a great product. Then you have the dashboard that lets you integrate multiple technologies like car chargers and air conditioners and anything else you can think of. There'll be people out there who go, oh, I know exactly, I've been trying to solve this problem, and we don't even know what the problem is, but it's just a communication question. Can you talk to the device? Can the device give you a value? Can you write a rule about the value? So it lets you be really creative beyond what we could imagine with your devices.
Right,
So
giving the power back to the end users or the system integrators. Yeah,
exactly right. Yeah, and if you have some kind of custom website you need that is, that really requires attention and someone's happy to pay for it, it doesn't take much to develop a custom page or something that suits the customer.
Yeah. Wow.
Yeah.
Wow. Great solution. Well, thanks, Paul, for telling me about this. Is just an awesome little device. I'm amazed what we've managed to pack into this.
Yeah, it runs at 1% CPU usage typically. So it's got a lot more headroom to do more things. We're talking about doing a colour display for it soon, but we haven't done that yet.
Yeah, or mining Ethereum.
Yeah, I'm actually doing that right now. I've been mining Ethereum for about, I'm not sure how long now, but maybe 9 months. And it's interesting actually just to do it because I had to build my own cryptocurrency mining machine and
Yes.
get all the code to work and have a wallet and everything.
Yes, I read today that they've dropped their power consumption by 99%. By changing the algorithms.
By changing the algorithms, yes, that's true. Yeah.
That's amazing. 'Cause, I mean, that's been the big criticism of cryptocurrencies, particularly Bitcoin.
Well, it's only criticism if you're not making it with solar power, of course.
Yes,
and you
true.
don't want the waste
But
heat.
that's-
Now, my office is heated by my crypto machine.
Oh, wow. Yeah.
It's 1 kilowatt. It just keeps the office beautiful all year round. So I don't feel guilty at all.
What do they call that? Where you sort of have the output waste of another. So it's
It's 100% efficient.
yeah, 100%.
Yeah.
That's great.
I was going to have to put the aircon on.
Hang on.
Anyway,
What about
so-
summer?
Summer, I've set up. I haven't finished it yet, but I'm going to open the roof hatch in the office.
Okay, so
to let the heat out.
and also maybe the fans just blow the heat out.
Yeah, maybe, yeah. And it's solar powered anyway. So
Cool.
Yeah.
Oh well. Well, it's been great talking to you, Paul.
Good one. Thank you.
Thanks.
No worries.
Okay.
Bye-bye.